Hello, welcome to Earth Engine tutorial episode 50. In this video, I'm going to show you how to create some high quality maps using the cartoee module. The purpose of this tutorial is showing you how to create some static maps because most of the maps we were working on, they were usually interactive. Sometimes if you want to insert some maps into a report or a journal publications, you might need some static maps. So this is how you can showing you how you can create some of these maps so that you can export the data from Google's engine and use that to create maps. With that being said, let's get started. So first you need to go to the gmap.org to download the notebook example. Once you are here, you can click the notebook section and select number 50, cartoee quick start. Once you are here, you can click the download icon, click here and download this one to your computer. Hit save and keep that in mind because this one we're using some additional Python packages in addition to Gmap. But load, for example, the cartoee and scipy, these packages are not the required dependencies of the Gmap package. The reason for this is that some of these packages might be difficult to install on some operating systems, for example Windows. So I don't include this as the required dependency. You have to install this one, and I show you the steps in here how to actually install this step by step. And next I'm going to show you how to install. So let's get into it. So let me check this and open my terminal. So to install this and show you how to get that running on your computer. So first of all, we can create a new environment. So conda create -n carto. So this is what the name of the environment that we use. And if you already install Gmap or already create a conda environment, you can also install directly to the conda environment that you already created. But I'm just going to create a new one just to show you how to get a fresh conda environment to install. So once you copy and then paste, hit Y, and it's automatically download all the packages. And then we need to conda activate the carto environment. After that, we're going to use Mamba. The reason for this is this one is much faster for compared to conda install. So we're going to use the Mamba. You can also directly use conda if you want, but sometimes it might take a long time to resolve the dependency. So we are going to use this and hit Y. Okay, so next we're going to install first the cartoee and scipy packages, and after that we can install the Gmap. So copy, paste, hit enter. As you can see, so this is the beauty of Mamba. It resolves the dependencies pretty quickly. If you use conda, sometimes it takes minutes. So I'm gonna hit Y, and it's going to automatically download all the packages and resolve all the dependencies. It should be pretty quick. And next we're going to install the Gmap package. So copy, paste, and then Y. And the last step is to open Jupyter Notebook. So all we need to do is just type Jupyter Notebook once it's finished. And so as you can see, first we need to download the notebook example. So I'm going to copy, click the download icon here. Oh, looks like it's already downloaded. So, and probably I need to reopen my browser. Okay, so it's here, and we're just waiting for this one to finish. Then we can open Jupyter Notebook to start doing coding. Okay, so almost there. And so I downloaded this one to my downloads folder. In your terminal, you can cd, for example, cd and then downloads. So they get into the downloads folder, and then just type Jupyter Notebook. It should open the tab in your browser. If it doesn't, you can click here to open it, and so now we can open the notebooks. So we finished all the steps in here. Next, we're going to go through step by step how to create some nice maps. And so this the cartoee module was contributed by Kale Marcotte, and also this notebook was also developed by him, and so a big thank you to him for developing this nice module for GMap. And okay, so let's get right into it. First, we need to import the libraries. We need the Earth Engine Python API, the GMap, and also the cartoee module. So you can import all this. Also, we use the magic command pylab inline. The reason for this is we need the matplotlib library. So this one basically takes care of all the importing all the libraries required for this tutorial, and just hit run. Next, we need to initialize. If you use a GMap create an interactive map, then you don't need this one. So because in this tutorial we don't actually use GMap to create any interactive map, so we just call this function initialize to authorize the connection to your Earth Engine account. Once we have that, then we can request some Earth Engine images. So in this case, we are going to use the digital elevation model at a global scale. So we just request the EE image. Next, we specify a region we want to work on. In this case, we are using global scale, but we use the latitude from -60 to 85. And we also set the minimum and maximum visualization parameters. So this is how we're going to visualize the image. And run. Now, the last step is to create a map. So keep in mind, these are the data set in the cloud, and we're trying to set the parameters how to visualize. And so the next is to actually create a map. So we use the PLT, this is the pyplot from the matplotlib library. PLT.figure, and then we set the figure size. So it's horizontal and vertical. So this is like inches, 15 inches and 10 inches. Once we create the figure, so you can think about this as a paper. So we're trying to basically draw something on the paper. Then we need the paper first. So this one create the paper, and after that we can use the cartoee modules to get map. So essentially this one retrieve the Earth Engine image as PNG smaller pieces of images, and then put them all together. This one here specify the reason how we what's the reason we want to use, and how we're going to visualize that. And once we have this one, basically this is right now is the map. And so we're going to add a color bar, and also let me execute maybe first, and then you can see what it looks like. So this is the final output of this code block. We create the figure, and then we get the data, and then we plot the data onto this figure. And this is the reason we specify, right, from -60 to 85. And also we set at the color bar. So the color bar is this one at the bottom here, basically showing you the color map of the data set. And so we can pass in the parameters. Axis is basically the map, right? And you can also set the visualization parameters. So this one is the same we use to visualize the data. We put the color bar at the bottom, right? The color bar is actually at the bottom of the map, and the label is this one here. Also the orientation horizontal. You can put that also at the right here. Change this one to vertical if you want. Also, we add the grid lines. So you can see here the longitude and latitude grid lines, interval 60 longitude and 30 degree latitude. So if you see from here, with 180 to 120, right? So the interval is 60 and this one is 30. So you can adjust those parameters if you want. The line style here, basically you use the dotted line style. You can use a solid or dash other style if you want. So this also parameter is inherited from the Matplotlib library. You can change this if you want. The last one is to add coastline, red color. So you can see here, this is also the embedding one. You can see here the coastline, red color. And then we show the map. It's very simple and straightforward, right? So create a map and then get the Earth engine data plotted on the map, and add color bar, add grid lines, and add coastline. So you can add some additional steps to the map. Next, I'm going to show you how you can make better. This looks pretty nice, but as you can see, we use the gray scale color map, but we can actually change it to color scale. So let's execute this one. And most of the steps here actually very similar to the previous one. As you can see here, right now we add additional. So this one called different color map. So this color map all from the Matplotlib color map. So you can use any color map that's supported by Matplotlib. And all the other steps are very much pretty much the same, right? We get the map and then we add the color bar. But this time we add the color bar to the right, as you can see here, and also the orientation to vertical, right? So we get it to the right in here, and we also get grid lines. But you also might notice, so this time I use dash, so you have two hyphen. This one right now changed to dash, and also add the color line. You can also set the title. So now we use we add a new title compared to the one we used earlier, right? So this looks much better, and this is something you can right click, save as. So I can, for example, save as, download this one to my computer, and then you can open. All right, so and then you can zoom in, you can zoom out. If you think this the quality is not good enough, you can also change the DPI. So by default the Matplotlib use 100 DPI. So if you want a higher quality, you can, from here, before you create a map of the figure, you can change the DPI. So I'm going to change to maybe DPI to 300, and this one again, you should get a much larger map. So you can see right now looks much larger. So let me save the image again, download, and if you open, now it looks much larger. So if you zoom in, it's the quality is much better than the one we used earlier. Right, and you can zoom in, you can zoom out. So pretty nice, right? And so this is showing you how to create one map. Compared to the JavaScript API, there's no way that you can actually create this kind of high quality maps. You can take the screenshot, but those are usually not the ideal maps you want to get. And next, I'm going to show you how to add plot RGB map. So this is what's one single band, but if you want to get some multispectral image and display on the map, you will need additional bands. So in this case, we're going to use lane set image. So if you see here, this is ID. You can change it to any multispectral image, Sentinel or lane set. Once we have this, we want to customize how we're going to visualize the data. So very similar to what we did earlier, but this time we added the additional parameter called bands, and then B543. So also the minimum and maximum, and also the gamma. Execute. Let's see what we get. Okay, so this is one entire lane set scene that we get, and let's look at the source code. So again, we use the create the figure, and then we get the map. And so this one here, we pass in the image. So this one is Earth engine image object. If you want to see like what other parameters you can provide, you can shift tab, and then to open up the tooltip to see some other parameters. So the first one here is the image object. You can also change the projection. So this will be the next tutorial showing you how to change the projection, but we use default one, and you can provide additional arguments. So those arguments is, for example, you can change the visualization parameters. Once you have this one, we also use the pet view, because earlier if you don't use this one, it's basically to the border. Everything is like, if you use the pet view, we create some basically not get into the border, so you can have some pixels, some white area between your map and the border, and this is what it looks like. So if you see from here, this is what we use, why we use the pet view. And lastly we add the grid lines and also the tick marks, if you can see from here. But we also use the rotation 45 degree, and this is what it looks like in here. You rotate the label 45 degree on the x-axis. So this is for one entire image. If you want just a small subset of the image, you can also specify the region. And let's try this one. Similarly, we create a map, and then we specify this region, and from this one you can pass into the region parameters in here. So get map image, how we want to visualize, and we just want this specific region. Everything else remain the same. So now you can see this image, right? It's only one small section of the entire image. Again, everything else remain the same. So you have the label on the x-axis and also on the y-axis. Lastly, we might want to add some add a nose arrow and also a scale bar, to showing you like what each pixel the distance represent. And so we add two additional functions, add nose arrow and add scale bar. Let's execute and take a look at what it looks like. Create a map, specify the region you want to plot, and get the map, add the grid lines. For this one, since the interval is pretty big, so you don't really have to rotate the label 45 degrees. So I can just keep this one, delete it, or you can change it to 0. In that way, you'll be just horizontal if you have enough space, right? So now you can see here, not without the rotation, looks good. Then we set the grid line and also coastline. So these are the two additional ones that we just added. We add the nose arrow, right? And then if you want to see like what parameter you can provide, you can again shift tab on your keyboard to bring up this one. So just shows you what kind of parameter you can provide. And the XY is basically the location where you want to put the nose arrow. So this value is from 0 to 1, and as you can see from here, it's basically a tuple, a pair of coordinates. 0.05 basically is 5% of the x-axis. So this is the nose arrow, as you can see from this one here, from the lower left corner. So this is 0 and 0. This is upper right corner is 1 1. So 0.05 basically means the 5% of the x-axis. So this is the width is 100%, so 5% is roughly in here. Also 25% of the y-axis. So this is where the point, the location of the arrow is 25%. And you can see the height, right? So roughly this is 1/4, and you can see here. You can specify also the length, also the width of the nose arrow. So you can see. You can specify this one here, for example, the width and also the head width. These are all things you can customize. Also the arrow length. 0.1 basically is 10% of the height. 10% of the height of the entire image. Okay. So next one, we add the scale bar. This is what the scale bar looks like. Right now, due to the limitation, you can only get something, the style we're going to look like this. It's not going to be as fancy as other desktop GIS. Similarly, you can specify the length, right? 10. So the unit, we're going to use 10 kilometers. All right. Yeah, this one here looks the unit kilometer, and then the number is 10. So you can specify 10 miles or 10 meter, 100 meter, or whatever you like. Also, the location XY is the same, is similar to this one. So XY 10% on the X, and also 5% on the Y. So 10%, basically the length of from here. The center is going to be 10% of the width. Also, you can change the font size, also the color. They said I can change, for example, to red color and see what happens. So the arrow color, and also maybe this one, the font color, change to red. You can also provide any hex color code, right? So now you can see here all the red color. You can also change to color code, for example, hash, and so the arrow color we can change maybe to blue, right? RGB, so it will be 00, like 00 FF, red, green, blue, right? If we use this, you're going to change to blue color, and similarly you can do this one, do the same thing if you want. They don't have to be the same color. You can provide whatever color you want, right? And you should get this one right now. It doesn't look good, so we probably want to just change to the white color. If you use the name of the color, then you don't need the hashtag. So I'm going to use this. Also, you might notice that the quality might be high enough. Again, as I mentioned earlier, you can change the DPI. So you can go back to the beginning of this line, and then I can change the DPI to maybe 300. DPI equal to 300. Once you have this, you can then download the map, and then you can insert this into a report or a journal article that you want to submit to a journal. Right click, save image, and then download, and then open. So now you open using a image viewer. It looks pretty sharp, right? So much better than you take a screenshot of the map. Right, so you can see, you can zoom in, you can take a look. You can also change the title and everything. So highly flexible. You can customize all the parameters. Okay, that's all for this tutorial. Hope to see you in my next tutorial. Take care. Bye bye.